start with the core mission of the project, and it is to develop and produce advanced carbon-negative fuels from low-grade waste biomass. And we do that by using 4 thermal and electrochemical processes, which starts with the first one, which is a catalytic pyrolysis unit, the TCR, or thermal catalytic reformer. And there we produce biochar and bio-oil with CO2 as an inert gas. The next step is the PSA. The PSA is the pressure swing observation, and there the hydrogen gets separated from the syngas stream and can go together with the bio-oil to be refined to either diesel or to gasoline. The syngas stream continues to the oxy-fuel combustion, where the gas is combusted in an oxygen-rich atmosphere to produce on one side heat, but also a clean CO2 stream, which then goes to the PEM, to the bioelectrochemical methanation unit, which together with power synthesizes from the CO2 the synthetic methane. And as you can see, there are many interconnections and products and inputs and outputs. And to all of these points, we can attach, or these are like attachment points for other industrial symbiosis and processes. And as an example, we've got here the oxy-fuel combustion, because for the oxy-fuel combustion we need or we require oxygen. This may come from a nearby steel plant or from directly from an air separation unit. And conversely, net fuels can provide other processes with TCR oil, biochar, or synthetic methane, for example, for industries like chemical, refinery, or agricultural. And to systemically map these interactions and symbiosis effects, we made a detailed analysis of all the products of net fuels and linked them to the NACE codes to get basically a blueprint for the cross-sectoral integration opportunities. And to even enhance and boost these symbiosis effects, net fuels is designed with a modular and flexible approach. We mean by that we can use different setups and use cases, so different setups for different use cases. The first one is the full configuration, which uses all the core technologies of net fuels and provides the maximum carbon negativity. The second one is the simplified agro-industrial setup, which is perfect for rural and decentralized areas where there's a lot of biomass. The third one is even more downscaled with the TCR alone, just produces the TCR oil and biochar. And the last one is the PEM standalone, which can be used as a, for example, biogas upgrading plant. And with this modular approach, we're able to adapt to very many different contexts in rural and industrial areas. And we come to this real case scenario, the random use case. And here there is not only the biomass is provided locally by the farmers there, but there's also a very good connection to the logistical supply chain. And there's also a wide range of different industrial sectors, which not only provide the inputs for the net fuels, but can also use the outputs of net fuels. And with that, this connection can evolve along the trajectory of the EU to produce carbon negative and carbon removal networks. And here we listed some companies together with the technologies and also the opportunity for net fuel symbiosis. And to get more specific, we picked out one specific use case, which is the setup number 2, TCR and oxy-fuel combustion, which would work perfectly for bitumen production. And we have hydrogen as a oxidation control. Then we have the TCR oil as a bio-based fluxing engine, and also the bitumen can work as a filler or substitute. The biochar can work as a bitumen filler and substitute. And now I talked a lot about net fuels itself in the project, but it's not a project standalone. It's also aligned with the carbon removal and carbon farming regulation effects between industrial processes, and just within the Ravenna we found over 50 synergetic processes. And with that, our vision is to not focus on one plant, but we want to design industrial districts which are intrinsically linked to each other, where the waste from one is the food for the other. And by that, we're capable of transforming existing industrial clusters into decarbonization and defossilization ecosystems. And to do so, we're always open for inputs and collaboration. So if anybody of you has inputs for us, we're happy to take them, and we're outside afterwards. So please come to us and talk to us. Thank you very much for your attention.